This is question 9.2.21. I'm given a simple random sample of size n. Looks like the sample size is 34. I have a sample mean x bar is 18.8 and the sample standard deviation s is 4.7. When I'm given the sample standard deviation s, I know that I'm going to use a t interval. I don't need this table of areas under the t distribution because my calculator will calculate these for me. So I'm going to go to second bars. No, I'm not. I did this last time. I'm going to go to stat tests and I'm going to go to t interval. Let's see where that is. That is number 8. And I did an example that with data, but this one doesn't have a data set. It has statistics. So I'm going to use my right arrow key so that statistics is highlighted and hit enter. And then I'm going to have to put in the data. So my x bar is 18.8. I'm just stealing that from the question. My sample standard deviation is 4.7. My n is 34. Again, all of this is given to me in the problem. I want a 95% confidence interval, and then I'm going to calculate. And I'm supposed to round to 2 places, and I have 17.16. Oops. And I have 20.44. And I'm going to check my answer, and it looks good. And then it says, what if the sample size is 51? So for that, all I'm going to do is go back and to that t interval. I wonder if I could just hit 8. Oh, I can. And I'm just going to change that n to be 51 instead of 34. So now I have a slightly larger sample size. I'm going to calculate that. And I get 17.48 when I round to 2 places and 20.12. And that looks good. And now I'm supposed to see what happened. When I increased the sample size, noticed what happened is my confidence interval got smaller. I got more accurate as I increased the sample size. So the margin of error, which is the distance from the mean, 18.8, to either side, 17.48 or 20.12, that decreased because it was larger here. The distance from 18.8 to 20.4, for example, 0.44 is longer than from 18.8 to 20.12. I'm going to check that. Looks good. And that is using a t-interval with stats. To construct a 99% interval, I'm going to, again, go back to that test. And I'm going to change n back to 34. But this time it wants me to do a 99% confidence interval. So I need to change that 95 to 99. And I get 16.59 or 16.60 when I round to 2 decimal places and 21.00. And then they want me to say, how does that compare to a 95% confidence interval? So 1, I changed the sample size. 2, I changed the confidence level. And notice the margin of error increases. I have a wider interval. That's so I can be more sure. I'm more confident if I have more values to look at. What if the sample size is 17? What conditions must be satisfied to compute the confidence interval? Since this is such a small sample size, I have a choice. The sample must come from a population that is normally distributed, and the sample size must be large. The sample data must come from a population that is normally distributed with no outliers, or the sample size must be large and the sample should not have any outliers. Let's see what it says about B. The reason I picked that one is I don't have to have a large sample size if I come from a population that's normally distributed with no outliers. That allows me to have a smaller sample size and use the t-distribution. Hope that helps you.